Okay, so now for our second part of exponent laws, we're going to talk about quotient rule of powers. So with quotient rule of powers, we need to understand that multiplication and division are related. And with our product of powers, maybe you just watched that video, we added the exponents. Well, quotient rule, we would do probably the opposite, since multiplication and division are opposites, which would be subtraction, which in this case is correct. Okay, so when we are dividing exponents, we subtract the exponents from each other. Okay, let's go and talk about y first, so you're not just, believing me. Let's say that let's just give m a number. So let's say I have a to the 7, and let's say I have a to the 3rd. Okay, well, if we write this out, I have 7 a's, 1, 2, 3, 4, 5, 6, 7, and then I have 3 a's. Okay, well, what happens here is that a over a is 1, which means it cancels. So I cancel this, I cancel this, I cancel this. What am I left with? 1, 2, 3, 4, a to the 4th. Well, what's 7 minus 3? 7 minus 3 is 4. So that's where the quotient rule comes from. Now, if you're asking, well, why do they cancel? Well, they cancel because, remember, any number over itself is equal to 1. Well, 1 is just, I can put a 1 here. There's a 1 there. We can put 1, 2, 3 ones here if you want. That's tedious. We don't need to write that. Okay. Whenever you have a 1, it essentially makes it cancel. It makes it go away. Okay. So let's go and look at a couple examples. Okay. We'll go and look at 4 here. So we have number 1. We have m9 over m5. Okay. And I guess one thing I forgot to state, which you've probably picked up by now, but again, they have to have the same base. If you don't have the same base, you can't subtract them. They have to have the same base. Okay, m9 over m5. So we have the same base, we're good. And then the way I always do it, instead of, we don't have to write it out every time, but I always say the dividing bar for exponents to me is a minus sign. I just think that's a minus sign. 9 minus 5. So I know I'm m4 is my answer for that one. m4. Okay. Number 2. Okay, we have a little bit of extra to do here. Okay, so I have a product powers on top. So that's from our last lesson. So I know I have a B1 and a B4. That's a B5. Right? 1 plus 4. Same rule we just did last time. And then I have over a B2. Now I can do my division rule. Okay, because I'm fully simplified. I'm ready to go ahead and do my quotient rule, which is 5 minus 2, which is B3. Okay, just one step to the next. Okay, and this one's kind of got a lot of stuff on it. It's kind of like with one of our product of powers problems. But I'll show you how easy it is to sort through this mess. Okay, alright, so first thing, I have A's, I have B's, and I have C's. So I have 3 things that are related in terms of their bases with exponents. These right here, these are just numbers. Just treat them normal. So all you have to do for these is, what's negative 12 divided by negative 2? Well, negative 12 divided by negative 2 is a positive 6. Okay, and then I have A7 over A5. So remember, I said, think of this right here. This is a minus sign, dividing bar. 7 minus 5, A2. 10 minus, well, there's nothing on the B, so what is it? It's a 1. So 10 minus 1, B9. And then we have 5 minus 4 is 1, so it's just a C. You can put a 1 up there if you want, but again, their book won't do that. So that's what number 3 is. Alright, and let's just see if I can squeeze the last one here in the bottom. We have 4 to the 8th over 4 cubed. Okay, again, this is kind of like with the product thing. You do not divide the 4s. The 4s don't make a 1. Okay, just like we didn't multiply the 4s when we're doing the product rule. Because we have 8 4s, and we have 3 4s. So we have 8 minus 3, we have 5 4s now. That's all you want to do. Leave it just like that. You can evaluate it by putting your calculator if you want to get the actual number of 4 to the 5th. Okay? And that's it for quotient.